Hey everyone, I'm not Dan, but in this video I'm going to show you how to calculate percent composition. It's Welcome back. Before we get on into it, be sure to grab your calculator and your periodic table and I will see you on the inside of the computer. Let's go.
What's up everyone? I've got a couple examples to show you of how to calculate percent composition. Alright, so let's get into it. So first off, up here we've got good old C6H12O6, otherwise known as glucose. Alright, so what we're going to do first, step one, is to figure out the molar mass of this compound. Alright, so same as we did before. So carbon here has a mass of 12.0, and we're going to multiply that by how many carbons there are, which is 6. And so when we multiply that out, we get 72.0. Hydrogen here has a mass of 1.0. Multiply that by the number of hydrogen atoms, which is 12, and that one is obviously 12.0. And then oxygen has a mass of 16.0. We're going to multiply that by 6. And when you multiply that out, that is 96.0. Okay, and now all we're going to do is just going to add that all up, and we get 180.0. And this being molar mass, the units are grams per mole. All right, so now that we know our molar mass, what we're going to do here is we're going to take each of these individual masses, divide it by the total mass, times 100. Okay, so let's see how it works. Okay, so carbon has a mass of 72.0, and we're going to divide that by 180.0 times 100. And so when you calculate that all out, that actually comes to 40.00%. Now, yes, I know the calculator does give you straight up just 40. But I like to round percent composition to the hundredths place. Obviously, you need to round it to whatever your teacher tells you to do. This is just what I like to do. Okay, and then hydrogen has a mass of 12.0 divided by 180.0 times 100. Okay, and that comes out to 6.67%. And then oxygen is 96.0 divided by 180.0 times 100, and that comes out to be 53.33%. Okay, so we have now successfully calculated the percent composition of carbon, hydrogen, and oxygen as they create glucose. All right, I got one more example to show you here, which is copper 2 nitrate. So same as before, step one is to calculate the molar mass. All right, so copper here has a mass of 63.5. Remember, I like to round my molar masses to the tenths place. So 63.5, and then we're going to multiply that by the number of coppers in the compound, which in this case is 1. Okay, so that equals 63.5. Nitrogen has a mass of 14.0. Now, how many nitrogens are we going to multiply by? Well, inside the parentheses in nitrate, there's only one nitrogen, but there are two nitrates right here, right? So that means that overall there are two nitrogens. Okay, so that equals 28.0. And then oxygen, once again, has a mass of 16.0. Now there are 3 oxygens in nitrate, but again, there are 2 nitrates, so we multiply that, 3 times 2, to get 6. All right, so same as before, 16.0 times 6 equals 96.0. And now we just add everything all up together, and that equals 187.5 grams per mole. All right, so now that we know the molar mass, we're going to divide each of the individual masses times the whole. All right, so here we go. So copper has a mass of 63.5 divided by 187.5 times 100, and that comes out to be 33.87%. Okay. Nitrogen is next. Nitrogen has a mass of 28.0 divided by 187.5 times 100, and that equals 14.93%. And then last but not least, we've got oxygen with its mass of 96.0 divided by the total mass, which is 187.5 times 100, and that comes out to be 51.20%. Okay, it's really quite simple. Once you get the hang of it, you literally are doing the same thing every single time. So remember, step one is to calculate out your molar mass. Then you take each of these individual masses divided by the total times 100. All right, thanks a lot, guys.
Well, thank you for watching. If you have any further questions, be sure to comment below. And if this is your first time watching, thank you so much for joining us, and be sure to hit that subscribe button. Remember, I'm not Dan, and neither are you. Check you later.